So we'll wait for I guess around like 5 minutes for everyone else to join, and by that time then we'll get on with the session. Quite a few familiar faces out here. No one's interested in cars. Just feel free to unmute. If you don't want to unmute, you can put a bit in the chat box. If you want to discuss about some new developments in the automotive field or things like that, we can chat about that and all the new EV concepts that are coming out. I'll share my screen and keep so we can directly start. Guys, note to everyone, just make sure that you are pinning the presentation screen so that that will be the biggest screen to appear on your window and you'll be able to view it easily. I see there are quite a few motorcycle enthusiasts out here, huh? So, what do you guys think about the new Ultraviolet? The not new exactly, but it's going to release very soon in the next couple of months, they say. So Madhusudan has something to say. Any thoughts on two rear wheel motor, like two rails wheel connected with hub motor? So Madhusudan, wouldn't that make it like a rear wheel drive car itself, right? Just EV powered. And according to me, like when you're going the EV route, and if you're going to give individual motors to each wheel, you rather give it to all four. So you have even traction and much more control over the vehicle. So similar to an all-wheel drive car like the GTR or something. So that could make 100% use of the instant torque that an EV provides. Okay, so I guess I'll start with the session. Okay. So manufacturing concept cars. So I would, if anyone at any point of time has any doubts, you can put it into the chat box, or if you want to unmute yourself, turn your video on, communicate. That will be amazing, and we will keep the session as interactive as possible, and it will be fun for everyone, and it will be a great learning opportunity for you guys. And if you guys know something that I miss out or I may not be aware of, please share. So even I'll get to learn a lot from you. So now let's come to what exactly is concept cars or what exactly are concept cars. and how does this, this space in the automotive world revolve around, where a company decides to unveil something called as a concept car, and then everyone in the market is, flocking for that, a glimpse of that one vehicle. The people who have images of it will copyright protect it immediately, even before it gets uploaded or it gets to the common public. And why is it such a big hype? So things like these sketches are can be considered as the first budding idea of a concept car. Now, if you look at the sketches for concept cars, or if you even look at the rendered prototypes of concept cars, they are something that is so vague. So, sometimes it could be phenomenal looking, it could be very beautiful looking, or sometimes it could even be very weird looking to the common eye. And every time there is a change in the design language. So a design language is something that there are a couple of protocols that is followed by the design engineers. Of course, it is emphasized by the firm, and those protocols give birth to a completely different design. So about specific design languages, I'll be talking in the next seminar, that is for next week. But among that, one of the most famous design languages in India is the Impact design, or the Impact 2.0 design, that is patented by Tata. And that protocol, got the brand back up from where it had receded and, lost all its consumers. And so these design languages tend to work over there. So these design languages are defined by someone who has got massive experience in sketching vehicles or imagining vehicles in the 3D space, even without having a visual input towards it. So sketches like these, so now from the front view, this car would look very similar to the Audi R8, and at the rear, if you could see, it's something like a Lamborghini, Aventador kind of back that it has been given. So every idea always starts in the mind of the designer. After that, it is taken onto pen and paper, and here we have it. Now, another thing that you would notice, as I told you, the prototypes of concept vehicles. So this is the Nissan Juice, this is in the European market, Juke, sorry, Nissan Juke, which is in the European market, whereas I guess it's called as the Kicks in the Indian market. So if you see the car on the top, it is the concept car or the concept prototype, whereas the car on the bottom image is the actual road going version. So what are the key major differences that you can see out here? Eh, does anyone want to chip in out here and just tell me, what are the key major differences do you see in these two images? Come on, guys, let's keep this a bit interactive. It will be really fun.
Change in body styling.
Okay, change in body styling. So, Madhusudan, what exact change are you looking at over here? So, now if you see the top image, it looks very, funky as such, but the lower one looks like a very normal car. So, aerodynamic shape. Okay, that's a really good way to look at it. The lower car looks much less aerodynamic. But now, when you look at these two vehicles, right? Uh, the main thing that changes from a concept to a real world manufacturing vehicle is manufacturability, first thing, and second thing is the regulations. So there are certain government regulations which prevent a couple of things. So now if you look at these wheels, right, they tend to pop slightly outside the wheel arch. So they come slightly outside the entire car body. The wheels are much bigger than the wheel arch that supports in this particular design, whereas if you see, these wheels are sunken in. So this is to meet the guidelines for fenders that is given by various government bodies. Then second thing over here, if you can see, there's no place to hold a license plate in the front, and here they had to, you know uh, make place for a license plate, because that is the compulsory government regulation. This car does not have any mirrors on it, rear view mirrors, but cars, of course, any vehicle requires rear view mirrors, and so on and so forth. So these are the subtle changes that have to be made into a concept vehicle, and then only they can come onto the road. Now let's come to stages of automobile design. So let's think that, we are the guys who have thought of a design. We want to get that car onto the road. We own Money is not an issue. You have a complete company to yourself that can manufacture a car, and now it's your job to get your brainchild into the real world. So the first thing that you would do is you would sketch it. So sketching is basically showing the car in different views. Basically, you would show an isograph, like a view, third angle view from the front of the car. Then you show a similar view from the rear of the car, where you can imagine the car in a 3D space. Then you come to the three proper views, that is the front view, top view, and the side views. And then you go ahead with the processes. So your basic sketch would look something like this, where you just take like a really niche angle and sketch the car out. Then after that, there's something called as digital sculpting. Now digital sculpting is a very new age technique. Okay, so basically up until 5-7 years ago, digital sculpting wasn't a very big thing. It always was about CAD modeling, and when we say CAD modeling, it's softwares like SolidWorks, CATIA, NXCAD, PTC Creo, and things like that, that always dominated that segment. So the only way a car design could go from a designer's mind to for other people to view is via, either looking at the sketches and imagining it, which many people are not good at. Otherwise, they would have to wait for the design engineers or the surface sketchers to use AutoCAD alias and fill that model out. But now we've come to an age where computer technology has evolved to such a level where you can actually sketch in the 3D space. So you take those sketches, you import it into these softwares, and then start working on the car using these sketches as your base model. Now, what are these softwares basically? You have your CAD softwares that are really good for modeling. And when we say modeling means, you can take any of those models and take it to a CNC machine and get it manufactured. For example, if like you were to make a spear and with a hole in it, and you take it to a CNC machine, the machine will do it for you. And that's how modeling works on vector based technology. It does not work on pixels. So when you are modeling, you need to be very precise with your dimensions. Scaling the model, that is making a particular thing really big or really small, is very difficult when it comes to modeling softwares. And modeling softwares, you could say, have a limitation where it needs to be precise, because these are, when you come to the base of it, these are precision manufacturing tools. What these have replaced are those big drafters and draftsmen and those big draft benches that I many of you may not know this, but actual design started back then, where they would have these big draft benches and people would be sketching day and night, and those were actual design engineers of that time. So these CAD softwares came and made that life easier. But again, they need to be extremely precise, and when you give someone with an artistic talent things like a precision tool, he may not know how to use it properly. And it could be a very tedious process where you need a team of people, like you need engineers who know these softwares, and then you need these artists who have the ideas. And that would be that's a very commotion kind of scenario, where everyone's ideas are colliding, and then it needs to go back and forth and back and forth. So that's where these softwares have come in, called digital sculpting softwares. Now, what are these softwares? They are basically pixel based. So if you guys have used Photoshop or something like that, it is pixel based. So when you zoom right down to the very last pixel in an image, you see it's a square, a colored square. So these softwares work on rearranging these pixels and making different meshes out of it and creating complex surfaces. Now, if you look at this is a animated car, which is designed for some movie or something like that. And after a couple of renders, it would be rendered in such a way where if that render were to be placed into the real world, it would look absolutely real. So that's where these softwares come in, where it gives you an idea, a very good perspective of how the light is going to reflect off surfaces even before that car has touched the real world. It is everything in the virtual world. And now, since everyone is gravitating towards the virtual world, this has become a very common and a very important part when it comes to getting a concept car into the real world. Then you have the Ferrari Pista design, where if you can see, there have been different iterations that have been added to the bonnet over a period of time. Like over here onto the right, if you see, now this one is done to make the car look aesthetic as well as be extremely aerodynamic, because this is a performance oriented vehicle. So that's how currently, pre-CAD, you could call that, these softwares have been used. Now these softwares initially started for like the sculpting softwares started for people in graphic design. So Blender is one of those softwares that I could if I had to name one of those. There's Maya, then I guess there's ZBrush as well. So there these are the couple of softwares that can be used. So initially these softwares were only used for making 3D models, right, for animated movies or any kind of animated stuff. These things were used, but later on when people went through these softwares, they realized that we can use it as an engineering tool as well. And the best part of these softwares is the way they design it. Many a times you could take that entire design and import it to your CAD software, where your CAD software will compute the entire process and try and get as close as possible to the thing, to the sculpting that you have made. So the designers who are using CAD have got a very little amount of job to do when it comes to making the surfaces proper. So now as you can see, this is a car designed on SolidWorks completely. So now the surfaces over here are very 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 simple. uh, Creating, I'm not saying it's not possible, it is easily possible, but to create something like the 488 Pista in SolidWorks, where if you could see these crevices over here, this is a very indented and a very curvy surface. Then the bonnet indents, they are very curvy, and there are things like this which you need to focus on when you're looking at the two different softwares. So now anything modeled in CAD cannot be given that much amount of detail in a very less amount of time. It is very, very time consuming and very difficult to do that. So now as you can see, this is a CAD model which is completely prepared. Now you're looking at this car model, but it is not just one piece. It is made up of millions of pieces that have been assembled together. All these pieces have been made by different design engineers and different design teams, and then compiled together to give you this CAD model. Now what does this CAD model do? Now the CAD model is going to give you a very realistic picture. So now, as I told you, your CAD softwares are designed in such a way that when you take these models and put it into a machine, it can easily be manufactured. So now the CAD model takes into consideration all of these factors where manufacturability is concerned, safety is concerned. So now, as you're looking at the outer of the car, or the body in white of the car, if you had to say, uh, it has the hood, it has the side fenders, it has doors, it has the roof and things like that. So now these are the components that actually keep you safe in a vehicle. So it needs to meet various safety standards firstly. So when this car is designed, all of the standards are met, and then you get a very realistic picture of what is going to come in real life. Like as I showed you those two different images between the Nissan Kicks, the concept image as well as the real manufactured image. So that's how you could get an idea of this is the manufacturable car, and this is what will come on the road if the company decides to go ahead with this design. Then after that comes clay modeling. Now, what does clay modeling do? Now, clay modeling gets whatever is there on your computer screen into the real world. So, there have been holographic technologies that have been talked about, and there are like various, many different things that have been talked about over the years. But clay modeling is one thing that has lasted through all of these other technologies. This thing, clay modeling is a very old art, and it's a very skill based art, right? So different designers and different modelers work on these models. Now what clay modeling will do is take that image, take that that model that is there on your computer screen and get it into the real world. Now when you get it into the real world, what's the advantages is you get a proper 1:1 perspective. So generally they how they make clay models is there is a 1:3 scale, which say a full size SUV may be just this big. Then there is a 1:1 scale, and sometimes they even take it slightly bigger just to emphasize and see how these curves will look when close-ups are taken of these vehicles. And every company has its own protocols and own requirements for the different models that are going to be used. So then we come to this is a another example of clay modeling. Now, one more thing, if you notice in clay modeling, is this is the Land Rover that is being modeled, okay, an upcoming model. So, if you can see, the right side of the car and the left side of the car have got very subtle, tiny differences when it comes to this bash plate. So, the steel bash plate that they add, under an SUV to give it that rugged look, and also it, of course, works as a deterrent, of, as a first line of defense, I would say, for any kind of rocks and pebbles and anything that's going to be pelted on it. So if you could see, the right side of the car and the left side of the car will have very subtle differences, just to see which looks better in the real world. Because in the virtual screen, many a times things would look very beautiful, but when you get it into the real world, it would look very different. Also, the clay model works as a, you could say, a push pin, a pin bed, you could say, in a way, where the rear view mirrors, the plastic parts that are going to be manufactured, like spoilers and things like that, the headlamp units and things like that, are can directly be mounted onto the clay model to see how it looks on the vehicle, or whether you need any changes in those, or really really small differences, and that's where clay modeling kicks in. So now I have a small question for you guys. People who answer this correctly, I'll try and get you a really good reward, which you would enjoy. Uh, so what if we directly, go from sketching to clay modeling? What would happen if we directly do that?
Sir, how can we get the measurements if we go directly to the clay model?
If I give you a sketch with all the measurements in there and I tell you model it out, is it possible?
No, sir, is it not? It is not possible, I guess.
Okay, and why would you say it's not possible? Like,
Sir, uh, it will making clay model is maybe more different difficult directly without using the digital platform like CAD software or
okay,
blenders.
okay. That's a really fair answer, Dhruvesh. Yeah, multiple automotive styling errors. Madhusudan is very close to the correct answer. I'll give you the correct answer by the end of it, and less accurate in terms of shape design. Yes, this is also close one. It requires some skill. Okay, Sakib, you are on point over there when you say that it requires skill, because in for clay modeling, the guy who's doing that requires a lot of skill in the first place, just to do it from a model into the real world. But another thing is the aspect ratios. So aspect ratio is something that when a car goes from such a small screen to a bigger size, it looks very different many a times. Or the same thing follows from when you take a very big vehicle and get it to a smaller size. It may look the same on first glance, but when you look at it properly, you may need to change a couple of things. And there's a fun example of aspect ratio as well. And the most easiest way to understand this would be the surfaces. You cannot get correct surfaces when you go from direct 2D into the real world. When you're trying to do that, you cannot get complex surfaces in the first go in sketches, because as Dhruvesh said, there are no measurements. You do not know how much a part has to sink in, or how much radius has to be given to a particular corner bend, and things like that, where modeling kicks in over there. And now at this point of time, uh, as Dhruvesh was absolutely correct, you cannot do it. Even the best of the best surface modelers today won't be able to do it in a way. So that is why you cannot jump those steps. And the basically the digital modeling is also important. Now, the thing that I told you about aspect ratio is, if you guys are really interested in this, it's a very fun concept. Is if you were to take a Hot Wheels car, right? Maybe of a Corvette C7, for example, and then you take a Mattel car. These are two companies that make toy cars, right? Of a Corvette C7 itself, and you keep both of them beside each other, you would see a massive difference between the shape of these two cars. Now they both claim to be replicas of this real life vehicle, but why do they look so different? So the idea behind that difference is basically Hot Wheels. Right from when it started, those design engineers understood that when a car is shrunk down, and if the original aspect ratios are kept the same, the car would look little less, it looks slightly ugly as such. Not ugly, it won't be the right word, but if they change the aspect ratios, they could make a smaller model car look much better. So what they did was they flattened these cars and they widened these cars. So when they flatten and widen these cars, what happens is the appeal to the eye improves. So that's why, that's another reason why you cannot take a sketch into a clay model. Okay. Now, clay modeling also comes with a very big benefit. That is, there's something called as a silver foil. So a silver foil is going to be pasted. So if someone has ever got their vehicles wrapped or seen videos of vehicles being wrapped, you understand how this process will go ahead. The clay is going to be wet slightly and this film is going to be placed on it without any air bubbles. So it looks like it's painted. So the advantage of having the silver film is it's going to reflect light in a very different manner, giving the different shades into the car and giving the small cuts and grooves and crevices its own character. So now if you look at the air vent over here on the BMW, you would clearly be able to see that this shape, this is flowing upwards, and then there's a small indentation over here. So these minute details are impossible to see even on a CAD screen after zooming in. So that's how you get to see this with your own human eyes. And till today, there's no camera that can ever replace the human eye. So what the human eye can see will only be shown when it is brought into the real world and you can actually see it, touch it, and feel it on different curves and different crevices. Now, the advantage of this also would be that if any shape which is not aerodynamic and is not visible to your eye, is not visible in any renders or things like that, there are many a times that there'll be like a cut like an undercut or something which could cause a vortex or something like of those sorts and make the car kind of unstable. So that's again another advantage of clay modeling. Then now, let's say the flashy fun part of cars is over at this point. Let's come to the interiors. What are you going to see? Now imagine you are a multi-millionaire where you have got unlimited amount of money, you bought the best supercar that money can buy, or maybe you got the most luxurious car that money can buy. From outside, the car looks phenomenal, it's going to smash, and when you sit on the inside, just imagine this, it's completely made up of rods, cheap plastic all around you, and you've got a bucket, a plastic chair for a seat. Of course, that's not the experience you are looking forward to, right? So cars, apart from looking good and apart from the performance, also need to be slightly comfortable and at the same time deliver the value for money. So let's look at the interiors of a Bentley. Now there's going to be pine wood, there's going to be Alcantara leather all over the place. There's going to be everything is going to be of the most premium material that money can buy, right? And all of that, you'd be surrounded by that. Of course, cleaning all of these materials is a pain, of its own. But yeah, just for the joy of owning it, this is what you would expect when you buy something like a Bentley. But now imagine in a Bentley, you would have materials like this. So for a very long time, the cheapest car on Indian roads available was the Tata Nano. So imagine this is the interiors that you got into the Bentley. Now, why I'm talking about this cross scenario, or just imagine you would get the Bentley interiors into a Nano. That would be a dream come true. But why I'm talking about this is basically these interiors also play a key important role when it comes to design. Everyone talks about the exteriors of the car, but when you look at the interior parts, the interior trims of a vehicle, that's when you can actually make out the difference in manufacturing quality. Materials used are going to be completely different, because the company needs to factor in and budget in everything. Nowadays, all car manufacturers, if you look right from the windscreen onto the dashboard of the car, or you look at the steering, it looks like leather, but it is not going to be leather, because leather is very expensive to actually use onto in an automotive settings. You may get leather shoes and jackets and things for really cheap prices, but when you're talking about leather that can withstand the sunlight, like standing in sunlight for long durations, these things get really, really, really expensive. So people generally prefer to use textured plastics in the low end vehicle. Now this is the interiors of a Jaguar, where it lands exactly between, say, an economical car, whereas something as expensive as the Bentley So the Jaguar would hold a spot somewhere in between, like this. These interiors where you have certain amount of good leather finishes, you have a good amount of plastic finishes as well. So this aspect of design is, as I told you, generally looked upon. Like no one looks at it as much, and no one wants is interested in this part of design. But when a person buys a vehicle, the only thing that they are going to see and the only way that they are going to feel and communicate with the vehicle is with the interiors of the vehicle. So hence it's important. Now you design the exterior, you design the interior. Now let's come to prototyping. So what exactly is prototyping? So prototyping is something which is a term that is used in the industry really freely. And basically what it means is, you had a concept, you did your sketches, you did your calculations, you made a model that can work. I'm not saying has to work or it will work. It can function to a certain extent. So now in the prototyping phase, this is the point of time where every company goes all out, does every effort that they can, they'll just put into these vehicles and they'll get it onto the roads as soon as possible, and try and not get into the road, sorry, they'll try and get it into auto shows, things like MCA. And for India also, we have the automotive, the Indian auto show, which is generally in the central area of India. So these things, so companies want to get the product talked about. So as I before we even started, I was talking about the ultraviolet motorcycles. This bike has been in hype for a very long time. When they did the
Sir, your mic is off.
for how long has my mic been off?
Sir,
Hello? Yeah, yeah.
a minute ago.
Okay. So what all did you all miss? Like which slide did you all miss?
Yeah, sir, you was talking about the ultraviolet bike only.
Okay, great. So yes, so basically, about ultraviolet, so they got it into, they advertised it. Then TVS came in and put in 300 crore rupees, and that's where ultraviolet is today, and they can launch their vehicle. So that is every company's perspective to get an investment to, and if the company is already huge, something like Ferrari, they just want the word out that we are launching a new car, and people will already buy it even without seeing it most of the times. So like when the first La Ferraris came out, they just told that we are launching a car which is something completely different. It looks similar to the Enzo. It is based on the Enzo. Enzo is another car made by Ferrari. It's a classic car, and it was one of the fastest cars back then. So they said it, and people bought it even without seeing the model in real life. But not every company is as great as Ferrari, right? So they need to showcase their model. So here we have the Honda EV concept. Now if you see the design, it is a very different design, right? It may look ugly for some, it may look really beautiful for some. And this is the EV concept made by Honda. It's the Civic EV, and this is based on the oldest model of the Civic, the round headlamps that it came with. So it's things like this. Of course, this car is never going to see the light of day. When it comes to production, the car would be completely different, and it will look very, very monotonous on the road. But when you are unveiling something, the idea that you want is something like that. It is perfect because of teardrop rare design. Yes, this is a very important thing that Madhusudan pointed out. The teardrop design is that comes under the design language thing that I was actually talking about. It produces the minimum amount of drag coefficient, thus making your car perform better because it does not need to fight the wind resistance as much. That we'll talk in the next session in much more details, where I talk about how your car, basically the older models are being revamped and bought into the newer, in the newer ecosystem of vehicles, and yet can perform on the same lines while looking kind of classic and taking a couple of design cues. So then this is another prototype. Now this is a really ugly looking prototype in my opinion, because it does not have any kind of traditional car design that we look for. And this was the point where people were actually experimenting. This prototype is somewhere in the eras of the 2000s, where people were all over the place creating different models just to see what works. And then here we come with the 1956 Citron. It is a really horrible car to look at. The idea behind this was, make if teardrop is such an efficient design, we will make the car only into a teardrop. That was the basic idea. They took an airplane wing, cut it in half, took the aerofoil design out of it, and then I don't know what happened, and this thing was born. Of course, this car did not see the light of day. The moment this was unveiled, people hated it, and it never actually had a chance to establish itself on the road. And here we have the latest Renault Supercar. Now, I do not know whether this car has launched till today, but as you can see, the doors open in completely different directions, something like this. This thing is very difficult to manufacture, right? When it comes to manufacturing, when it comes to serviceability of these vehicles, it's going to be hell. But a prototype is something where the design engineers are just going to go ham, do the most craziest thing possible, and then just wait, take opinions, take ideas, and then scale it down and get something very moderate and very simple onto the roads. Now, looking at the two designs of the Honda Acura NSX. So to the left, you had the prototypes, right? Now, as I told you, like, design engineers will go crazy and do everything. Acura took a completely different route. They made a very simple looking car and they brought it to the motor show. They waited and listened to what people have to say. Everyone just told one thing: this car needs to be much more aggressive than what it looks like. And the older NSX had that aggression, had that driving control and things like that to it. So they were like, okay, cool, everything's fine. We listen to all these concepts, and now we'll take it back onto the drawing board. And that's when they got out the new NSX, which is absolutely like crazy aggressive. And in the next session, I'll be talking about this in detail, where I'll just give you all a small spoiler out there. Is this air vent, right? This air vent was a point of really big controversy when it came out, because people were like, this air vent does not have the feel. So if you look at something like the Ferrari, or like the LaFerrari, or you look at the Aventador or something like that, they have got massive air vents and scoops, which give it that that classic supercar personality too. So what Acura did with that is they also went ahead and increased this air vent. Then they made a couple of changes to the front Fiesta and things like that, and made the car much more aggressive. So now your prototyping is done. You have got everything that you need when it comes to styling perspective. Now what you have to do is get this car out and running on the road, because obviously a car is not going to be run on a racetrack for the rest of its life. So this is what companies tend to do. They will wrap their car in something like this zebra print and take it out on the roads, because this print is the worst print to reflect light. Basically, white and black zebra stripes is horrible to reflect light. And the reason being, so why you would put silver on a car is to look at every different curve, and why you would put this is to hide every curve. The reason being, they do not want their competitors to know about the most recent product, because R&D and testing in today's market is so very important. Because the moment a car is released, first you had owners who would purchase the car and drive the car for a bit and then see how it performs, right? But nowadays you have reviewers who see these vehicles, and reviewers will go down to the pin, and even the most comfortable car would be uncomfortable for these guys, where they will say like, okay, this car is not comfortable, this car has this issue and that issue and this issue and that issue. So that's why companies now have to test these cars out a lot on the modern roads. There is one company, I'm not going to name it, but they believed in public R&D. So what public R&D actually means is, it's actually a term coined by the common person. Is basically they would sell, say, the first batch of cars to people, then it would come up with massive amounts of issues. There would be gearbox issues, there would be heating issues, there would be some units that caught fire and things like that. And in the next update of that vehicle, they would resolve all of this, and that next model would sell like hotcakes. But in today's world, a company trying to do public R&D would be absolutely slaughtered. People who know about the company that I'm talking about, do not put it anywhere. Just laugh it out. Just don't name the company, okay? A company like that exists. You can go and search a bit. You'll get the name for it. So, can anyone tell me which car this is? Unmute yourself and tell me which car this is. Anyone? Any guesses? I'll just give you a hint. It's a sports car.
Sir, can you repeat the question, please?
Which car is this
Okay.
on the screen?
I guess it's the Cadillac.
Okay, it is. No, it's not a Benz. It's not a Cadillac. It is
Volkswagen?
actually a what?
Volkswagen?
No, it's not a Volkswagen as well. So it is the Corvette C7, the mid-engine sports car by Corvette, the most recent render of it. Uh, and I know you guys are not going to believe it, but this is what Corvette did. Where yes, actually, damn. So what they did was, when they got this car out on the roads and decided to test with it, they did not want their competitors to know about it, because the moment the C7 hit the market, uh, it even shook the doors of Lamborghini out there. So no one expected this car to be unveiled, because this was a completely super secret project, and it was kept under wraps for a period of time. So guys, I'll just be here in a minute. Just give me a second. Hey guys, sorry, I had someone at the door. So yes, so basically they did. Hello, you guys can hear me, right? Hello.
Yes, sir.
Yes, sir.
Yes. So yeah, so basically they did not want anyone to know what this car is. So so here they wanted to test the dynamics of the car. So now they couldn't get that car. They had kept it super secret, where even the people in the company didn't know what was being made. So basically the guys who were designing these cars, they were the only guys who knew what was happening. The guys who were working on small parts and all had no clue. So they took this car out, they drove it. They wanted to test only the dynamics. That is how the car performed under hard acceleration, under hard braking, under hard cornering forces. And that's what they did with this body. So this is the car that you're looking at. They put a pseudo body on top of it. And this is what it actually turned out to be. So if you could see, companies do that to keep things secretive, and that's what I was trying to emphasize when it comes to R&D and testing. Now let's come to manufacturing. Everything is done. Your car has passed R&D. Your car has passed all the safety regulations, and now you have been given the green signal to manufacture this car. So here, as you can see, you've got many robots working on these cars, and this is something that is true for a production line based vehicle. If you're going to talk about something like say a Rolls Royce or something like that, that's not a true production line vehicle, because a lot of things over there are made by hand. But 99 or 98% of cars in today's market are completely made on, mass produced on production lines. So this is just a a teaser image of what a production line would look like. And then you have these jigs, or the Biw fixtures that we call it. Now Biw is basically body in white, and it consists of every part in a car except for the internal seats or anything that is not metal. If I had to put it very simple, it is anything that is not metal. That is the front and the rear bumpers, the seat, the side skirts, sometimes and like the windshield, and anything that is not metal in the car is called as a body in white. It is basically the structure that is there to keep you safe and to keep all the components of the car in the car. So this big red thing that you see around this car is called as a Biw fixture, which is basically a jigs and fixture kind of thing, like a fixture which holds the car in place for various operations like welding, painting, and things like that, right? Then we come to the last point over here, that is distribution. You have made your car, you have tested your car, you have now produced it, people want to buy it, people have paid for it. uh, how are you going to get it to people? And that's where Mr. Jethalal comes into the picture and decides to go ahead and buy the cars from you at a particular price and then sell it out into the market. So that's the end of the presentation. Now, does anyone have any questions regarding this? Yes, Dhruvesh, that was actually true. That was the C7. So yes, guys, any questions? Feel free to unmute here. We can have a really good conversation, and I'll also be giving you yeah, hello.
Sir, can I ask question?
Yeah, sure, 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 sure.
Yes, sir. So, to work in this or to make a career in this field, so what are the options? Means after doing MSc or post graduation.
After doing okay, so basically after
Suggestion.
doing your masters, basically you would have to go ahead with design only as your this, because see, the automotive field now is a very closed industry, and to get in there you would need certain kind of experience, where freshers are not very welcome over there. So when you want to proceed with that, I would suggest is gain a couple of years of experience. And this is, I'm talking only if you want to get into design. If you want to get into analysis, there are some other means that you can get in as a fresher. But in design, you need to kind of prove yourself that you know what you're doing, and you're not going to wreck their designs or not going to waste their time. So that's how a design engineer is basically picked. So you gain a bit of knowledge from some sources, skill yourself up, basically. You understand the different softwares. Now basically your CAD software is going to be the same for everything. So you've got like Katia, you've got SolidWorks and things like that, and it is kind of, these softwares are common, and you have to understand what you're supposed to do. So when you're learning a particular software, you don't think about learning the software. What you think about is what you are going to learn. So we've got courses like plastic design, we've got sheet metal design, automotive sheet metal design, that is where you understand how to design these components. So when you sit for an interview for those particular positions, you can answer those questions much better, and they know that you can provide what they're looking for. So guys, I can see people leaving the meeting. Don't leave the meeting. You'll not get the certificate without the feedback form. So which is done before R&D and D and prototypes. I didn't get your question, Mod. Sakib, I have not got your question. Is licensing done before showing the general public? Yes, Madhusudan, it has to be done. So you can launch a prototype, but you cannot launch a working model into the market, basically without the licensing and without the government authorizations. Yes, yes, Sajan, you raised your hand. Okay, which will be done before R&D and prototype. So prototyping is done before. Working prototype is always taken in, and then the R&D is performed. So, guys, I please keep posting your questions. I'll try and answer them to the best of my ability. Along with that, I just have a small presentation now of the website. You can go and check it out yourself after after the session. Just give me 5 minutes of your time, and after that, what we can do is I'll give you the feedback form, and we can work on it. So, which type of designing job do we get in this field? Ahmedabad Gaming. I don't know your name, so I'll refer to you by that. But basically, which kind of job? The job that you will get in a design field is quite varied. You could go in for plastic design. You could go in for sheet metal. You could go in for the fixtures, the thing that holds those cars into places, things like that. You could also go for that. It's not change. I did not understand. Oh, your name. Are no, no issues, no issues about your name. Yeah, but yes. So that's the thing. So there are, it's very varied. So once you gain a bit of knowledge about all these different parts, the different domains in the design domain, that is subtypes of design, that's where you would understand where you want to be. That depends after you start working in the field slightly. Like, just view a couple of lectures or try a couple of parts by yourself, and then you'll understand which part do you exactly want to be in. Now, I'll just show you the website. So this is the Elite Techno Group's website. If you want to learn any of these, like want to work in these industries, I have a specialization course designed for this, where you could go through it once and see whether this thing will add value to your life. So if you come to go to internship courses, then come to design CAD and CAE, come to design CAD. Over there you could look at the third course, which is a specialization course. So I'll just give you a quick run through all the modules, basically what you will learn in there. So guys, who have got a doubt on how to enter this industry, just listen to this carefully for like 2 minutes and you'll get a fair idea about it. So first you learn about what? Hello? Yeah, so first you learn about automotive plastic design. So what exactly will you learn in automotive plastics is basically how to design the bumper of a car, the fender of a car, the plastic fender of a car, uh, the interior dashboard, then the inner panels, and you learn these things in much detail, where you will even understand how to manufacture these components, how to design these components for manufacturing, not manufacture it, but how to design it for manufacturing. And that is a very integral part if you want to work on the interiors of a vehicle. I personally have done automotive plastic design thoroughly and I've mastered that skill. Then you have automotive sheet metal design. Here you will learn how to make the structural members of the car, design it onto CAD space, and this is pre-analysis that we are talking about. So whatever the design would be, everything would be in your hands, and you would be deciding how these components would be shaped to accumulate a full frontal crash, side crash, and things like that. So you would be learning the different requirements over there, and you would learn how to implement it and build models in there. So here, and everything in this course is going to start right from the scratch and then take you upwards. Then you've got Biw Fixture Design. This is basically the fixtures that are there around a car. You learn all of those fixtures, how to design these fixtures for different purposes. As I told you, you'll have welding, you'll have cutting, punching, that is, then you'll have painting and oxidization, bath fixtures, and things like that, which you would understand. Now, the advantage of having these three courses, these first three courses, the first course and second course is going to use CATIA V5 and V6 for design. The BIW fixture design course will be using NXCAD. Sorry, UGNX or NXCAD is the same software, but slight differences. So for design, there's also a course on SolidWorks. If you want to learn how to use SolidWorks, basically, so you'll be learning the three major design softwares that are being used. Then you've got structural analysis of BIW, which is nothing but performing FEA, finite element analysis, on the structure of a vehicle, where you would understand how a car would behave under a crash scenario, or how particular forces, that is the weight of the car or the vibration of the engine and things like that, is going to affect the frame of your vehicle or affect the body of your vehicle. Then you come to automotive aerodynamics, where you'll understand how to design the outer structure of a car so that it has the least amount of aerodynamic drag, or and have the best coefficient over there. And then there is race car vehicle dynamics. So the vehicle dynamics course is also bundled over here to make it a complete package, where once you are done with this, you would specialize in multiple domains. So in future, if you're looking for a job and if you are sure you want to get into the automotive field, then these courses, like this bundle of courses, will ensure that you get in there somewhere, where you could pick your choice, like if and work on it even further. We've got experts who will help you out with that. And this course is in association with SAE India. So Society of Automotive Engineers, all of you may have heard about it by now in your engineering fields. So it's in ties with SAE India. A couple of projects that you'd be working on is the muscle car bumper. So basically, a bumper taken from a muscle car, the front bumper, that is a plastic based project. Then there would be interior design of a car. Then there's hood design of a car, and which satisfies crash requirements. So how a car would perform under crash, and how the hood would absorb damage and absorb impact. Then you've got SUV roof design, which is kind of complex, because SUVs are designed to have a rollover in a way when it's taken off-roading. So you'll understand about that. Then you learn to build the fixtures. Now the advantage of having these three courses, right, plastic, automotive, and fixture, is if you do not want to work in the automotive sector also, this thing will help you out thoroughly. Basically, you could learn plastic design and go and work in any plastic field. Like if you want to make mobile phone backs or design mobiles and things like that as well, that also can be done. So that is one thing. And now any doubts that you have, just go to the website, and there is a small button to the bottom right where it is ask an expert. So just click on it. A few details would be there. You could just fill that up and talk to the people about and get your doubts cleared about what these courses are, their prices and things like that. Now the specialization course currently is going out for around 60,000 rupees, because it is a combination of multiple courses. I would be sharing with you the coupon code, which is valid for only 24 hours. So if you guys decide to enroll, you could use the coupon code and get a 20% discount. Website link. Okay, Tanuj, just give me a second. Mm, Yeah, so basically, if you search for elite techno groups, the first website. Oh, thanks, Krishna. So why the designing the car shape will use R&D? Okay, so guys, you put your questions in here. I will answer them. I'll just put in the coupon code, and I'll also put in the feedback form, because a couple of you may be in a hurry because we only have 5 minutes left, right? So I'll put in the feedback form for you guys to fill out. Just give me a second. Okay. Yeah, this is the feedback form that I have posted.
Excuse
Okay.
me, sir.
Yeah, yeah, tell me.
Does the electric vehicles course deal only with four-wheelers, or does it cover two-wheelers as well?
The EV course, I'm not very sure because I'm in the design domain. And so you could just check with the councils, as I told you, just go to the website and fill your
Sure, sir.
information, you get information.
Sure,
But
sir.
what I can tell you from my personal experience is whatever you learn into the four-wheeler, you can incorporate it into the two-wheeler industry as well. Because except for just one key major factor that differentiates a four-wheeler and a two-wheeler is, on a two-wheeler you have got gyroscopic forces acting at a much higher pace, and that governs how a two-wheeler would respond in various situations. So that's the only difference. Otherwise, the design philosophies and the design ideas are shared between the two industries,
Got it, sir. Thank you.
and the dynamics are of course different. Okay.
Sure, sir. Yes, sir.
Yeah, Krishna. Thank you. So guys, any more questions? So I have pasted the feedback form. Please fill the feedback form. Under the feedback form, you also have the coupon code, so you could put in the coupon code, you get a 20% discount. And just talk to the counselors, and they would talk about how the pricing is. And the most important thing is, this thing is EMI based, so you do not need to pay the entire amount upfront. You could pay it over a span of a year. And guys, whoever in the second year, I would highly recommend you learn in second or third year. I highly recommend you take these courses, because by the time you're done with this and you're clearly, you've understood everything, it would be very easy for you to get a job when you're in the fourth year, or of course getting placed in a good foreign university or Indian university for your masters also will be great. It would be of great help. So currently I learn SolidWorks and AutoCAD. So that's what I was telling you, Ahmedabad Gaming, that SolidWorks is a software, but understanding things in SolidWorks. So we've got a course on engineering design using SolidWorks, where there are a couple of very important things like design for manufacturing and design for assembly and things like that, which have been taught, where you would understand the ideology of how you're supposed to design. So when you learn a particular CAD software and try to make things, you make it in a very haphazard manner. There is no particular order to it. So if you have a good order that you follow, that's when you'll understand how the industry operates. Any open source software if you want to suggest? Bhushan, unfortunately for CAD modeling, there's no open source software. For basically for sculpting, there is an open source software called as Blender 3D, which is completely free. It is a crowd funded application and it's open source. So it constantly keeps evolving, and it's a very fun software to play around with. But you cannot put that on your resume as a engineer if you want to go ahead with it. So by the designing the car shape, I used R&D. Santosh, if you're yet there, okay, Santosh has just left, so no issues. Okay, guys, any other questions that you have?
Sir, with respect to CAD modeling, is Fusion 360 suggested?
Yes, Fusion 360 is a good software, but depends whether you are, going in. So it depends which country you basically want to work in. In India, we have the three major players, that is NX, CATIA, and SolidWorks. And in India, we have these softwares that is the most used. In European countries, you've got PTC Creo, and Fusion is recommended for the United States. So if you're planning on working for Chrysler, planning on working for Ford, for GM, and companies like that, then Fusion would be a much better option over there.
Got it, sir.
Do we
Thank you.
need knowledge of two to three software for design or engineering? Gaurav, see, to be honest, you need knowledge of only one software. And the idea that, why we have included three completely different softwares owned by different companies is when you work on these different softwares, what you understand is these softwares are actually nothing. They are just tools to help you as a design engineer understand what you want to do. So if I already know how to design a particular component, for example, if I were to make this phone, right? So what I would be given by the company is just the back panel shape of the phone. And so that back panel is going to be given by the artist, and now I got to make a plastic component out of it. So this can be done in any software, but there are particular steps that you follow in each software, that and they will almost be the same, in the same ballpark, depending on which company you work for. So basically you take the A surface, then you take make a B surface out of it, you take a C surface, and then you make a solid body out of it. It's very simple, and then you start adding your design features. So the knowledge is much more important than understanding how to use these softwares. Guys, have everyone filled your feedback forms? Please fill your feedback forms. You won't get the certificates without that, as there's no way for me to contact you regarding that. Software used in European market for CAD and CAE. So Creo is a highly I would say favored out there for many companies when you're talking about European markets. Yes, the certificate will be sent in mail after you fill the feedback form. Thank you so much, Gaurav. Thank you. So everyone, have you all filled the form? If you have filled the form, you can leave. If you have any doubts, we can stay and chat for around 10 minutes more. Thank you, Adnan. Thank you, Madhusudan. And make sure that you're joining next week's session as well, okay? Everyone who are there. Next week is going to be even more fun, where we will look at how to take an older car and design it into a newer one, basically, and how companies have done it. Do you prefer connecting in LinkedIn for future contact? Yes, please do send me a connection request on LinkedIn. You'll find me with the same T-shirt out there, so that'll be easier to find me. Just search for Sheldon Coutinho, and you'll be able to find me easily. Thanks, Ajan, for joining. So I'll be there till 5, and then even I'll leave because even I have some more work after this. Thanks, Yuvraj. Hare Krishna, thank you for putting my link also over here. Send me messages on LinkedIn, it'll be great. I didn't get you, Sajan, what you're trying to say. If you could unmute and speak, it would be great. So, guys, I'll wind up the session now. You have any doubts regarding the course? Always hit the Ask the Expert session, and we can go ahead from there. Where am I from? Yeah, I'm from Mumbai. I'm in Bangalore. I'm all over the place basically. So you can contact me via ETG as well if you have any doubts. Okay, great. Great talking to you guys.
Hello, Hare Krishna bhai.